Dear students, welcome back to a new mathematics session. In today's session, we shall discuss a new chapter, that is the second chapter from the NCERT textbook, that is relations and functions. Let's move on to the topic. Let's begin with Cartesian products of sets. Here we are learning a new term, that is Cartesian product. Let's discuss more about this Cartesian product. Consider two sets A and B. Set A represents two colors, that is set of red and blue. And set B represents some of the items, that is bag, shirt and jeans. Set A represents colors and set B represents some of the items. So let's discuss how can we connect this set A and set B, means which are the possible pairs we can make it by using these two sets, set A and set B. Means first element of set A, that is the color red. Red we can connect with the bag, means red bag, red shirt and red jeans. So that we can write, that is red bag, red shirt and red jeans. Same way, blue we can connect with on each element of the set B, that is blue bag, blue shirt and blue jeans. Blue bag, blue shirt and blue jeans. And these are the possible pairs which we can make by using these two sets. And when we collect all these pairs and form a set, that set is called the Cartesian product. So there is a word Cartesian product. Cartesian product means we are making possible pairs by using the given two sets and collecting all these elements and making a set. Then we can call that set as the Cartesian product. Cartesian product is the set of all these pairs. How do we represent? Means we write Cartesian product as A cross B. A, then this is the into symbol and next is the set B. And we write as A into B and we read as A cross B. Remember, we read as A cross B. Then A cross B is equal to set of all red bag, red shirt, red jeans, blue bag, blue shirt and blue jeans. So this we can write as symbolically as like this. A cross B is equal to set of A comma B. This is called ordered pair. Remember, this is called ordered pair AB. And the first element A belongs to the first set, that is A, and the second element B belongs to the second set B. That is called, it is an ordered pair. Means first element belongs to the first set, second element belongs to the second set. We should not change this one. So A comma B is called the ordered pair. Why we are not allowed to change in the sense? Because this is the reason. A comma B and B comma A are not same. Means A comma B means first position is A and the second position is B. If we change the position, then the cross product also will be changing. So A comma B is not equal to B comma A. That's why this is called an ordered pair and we should not change the order. First element belongs to the first set and the second element belongs to the second set. Now let's take some more examples. Here there are three sets. A is equal to set of 1, 2, 3, B is equal to set of 3, 4 and C is equal to set of 4, 5, 6. Let's find out A cross B. So A cross B, when we take, first element is from set A, second element is from set B. So set A first element is 1. 1 we can make pair with 3, 1 we can make pair with 4, it is written. Next is 2. 2 we can make pair with 3 and 2, 4, that is written. Next is 3, 3 and 3, 4, that is also written. So A cross B is ready here. This is the A cross B set. Next is B cross A. When we check, first element is from B and second element is from A. That means 3, 1, 3, 2, 3, 3. It is mentioned. Next is turn of 4. So 4, 1, 4, 2 and 4, 3. So when we combine these two groups, we will get B cross A. So first we have taken pair with 3 and next we have taken pair with 4. So when we compare A cross B and B cross A, it is quite clear that they are not equal because the elements are not same. That means we can come to the conclusion that A cross B is not equal to B cross A. It's a very important statement. A cross B is not equal to B cross A. Then some important points we must note. Two ordered pairs are equal. Means ordered pair, we know that the position we cannot change. So two ordered pairs are equal means if the corresponding first elements are equal and the corresponding second elements are also equal. That means first element of one pair will be equal to the first element of another pair, and second element of one pair will be equal to the second element of the next pair. Then only we can say that two ordered pairs are equal. So let's take an example. If x comma y is equal to 1 comma 2, ordered pair xy is equal to ordered pair 1 2 means x must be equal to 1 and y must be equal to 2. X must be equal to 1 and y must be equal to 2. That is what the statement says. X is equal to 1 and y is equal to 2. Next is if n of a is equal to p, means number of elements of set A is equal to p and number of elements of set B is equal to q. There are p elements in set A and q elements in set B. Then A cross B will have pq elements. For example, if set A is having 3 elements and set B is having 2 elements, means A cross B is having 3 into 2, 6 elements. Means just to find out the number of elements in cross products, means just to multiply the number of elements of each individual set. So if A cross A means crossing 3 sets, same sets, is equal to set of A comma B comma C, such that A comma B comma C element of A, means all these 3 terms also from A set only, because we are crossing the same set. A cross A means all 3 sets belongs to the set A. Here A comma B comma C is called an ordered triplet. Previously we called it as an ordered pair because it is having only 2 elements. Here this is having 3 elements, and this type of arrangement is called ordered triplet. Here the word ordered is there, order is there. Because of that we cannot change the order. A first, B second, C third. Next we shall discuss the exercise questions. First question from exercise 2.1. If x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. Here left hand side there is one ordered pair, and the right hand side there is another ordered pair, and they are saying that these two ordered pairs are equal. We know that if two ordered pairs equal means their corresponding elements will be equal. That means here first element will be equal to here first element. That is x by 3 plus 1 is equal to 5 by 3. X by 3 plus 1, that is our first element, and here first element is 5 by 3. From here we are asked to calculate the value of x. That means plus 1 we can bring to the right side first. That is x by 3 is equal to 5 by 3 plus 1. When it comes to the right side it comes as minus 1. So here we right hand side little bit calculation is there that I will show you. So we have to take 3 as common LCM. When we take 3 as common LCM, this 3 we have to multiply with 1. That is first member is 5 minus 3 into 1 is 3. So that is the calculation here. So 5 minus 3 divided by 3. That is x by 3 is equal to 5 minus 3 we have calculated, that is 2 by 3. So here when we check, there is 3 is common denominator on the left hand side and right hand side. These two we can cancel, and finally we will be getting as x is equal to 2. So the value of x we have got. Next we will be going for calculating y. That is y minus 2 by 3, that is the second element, will be equal to here the second element, that is 1 by 3, because the corresponding elements are equal. So from here y we can calculate. Y is equal to this minus 2 by 3 will come to the right side as plus 2 by 3. That is equal to y is equal to here 3 denominators are same, directly we can take the common denominator, and numerator simply you can add, that is 1 plus 2. 1 plus 2 is equal to 3. Here directly we cannot add because here the denominator is not having. That's why we just multiply, that is 1 with 3. And here there is no problem, both the denominators are same. That means numerator you can simply add 3 by 3, that is equal to 1. So the value of x is 2 and the value of y is 1. Move on to the second question. If the set A has 3 elements and the set B is equal to set of 3, 4, 5, then find the number of elements in A cross B. Here set A has 3 elements. For finding the number of elements of A cross B, we need only the number of elements in each individual set. First set A is having 3 elements. Second set is given to us. So from the second set we can say that there are 3 elements. 3, 4, 5, there are 3 elements. So first set A is having 3 elements. Second set B is also having 3 elements. Find the number of elements of A cross B. Quite clear for us. Number of elements calculation is quite simple. Just to multiply the number of elements of each individual set. That means here 3, here 3. 3 into 3 is 9 elements. So let's calculate that. Number of elements in set A is equal to 3. Number of elements in set B is also 3. Just count and write. There are 3 elements. Then number of elements of set A cross B is equal to 3 into 3. Just multiply the numbers of each individual set. That is 3 into 3. That is equal to 9. So question number 2 answer is here. Next is question number 3. If G is equal to set of 7, 8 and H is equal to set of 5, 4, 2, find G cross H and H cross G. So these questions also quite familiar for us because we have done in examples. Here G set is given, H set is given. First of all, we have to go for finding G cross H. G cross H means first set is G, second set is H. So 7 we have to pair with 5, 7 we have to pair with 4, 7 we have to pair with 2. So 7, 5, 7, 4, 7, 2. Next element is 8 in the first set. 8 we have to pair with 5, 8 we have to pair with 4, 8 we have to pair with 2. So 8, 5, 8, 4, 8, 2. This is what G cross H. Next we have to go for H cross G. H cross G is equal to first set is H, second set is G. So 5 we have to pair with 7, 5 we have to pair with 8. The next is 4 we have to pair with 7, 4 we have to pair with 8. Next is 2 we have to pair with 7 and 2 and 8 pairing. So this is what H cross G. So quite simple questions, and make sure that due to carelessness you should not make any mistake. Next we shall discuss question number 4. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. So there are statements which is given to you. We have to check whether it is true or false, and if the statement is false, then we have to write it correctly. First one, if P is equal to set of M, N and Q is equal to set of N, N and N, M, then P cross Q is equal to set of M, N, M. This is what the statement. So here, first of all, by looking itself, it is quite clear this is a wrong statement because P cross Q is having only 2 elements, and here 2 element, here 2 element, means total P cross Q should have 4 elements. And here it is having only 2 elements. The statement is false, but we have to show. So P is equal to set of M, N, Q is equal to set of N, N. Then P cross Q, let's write. That is, P is first set, Q is second set. M, N, M, M. So that is what the first pair is. Then N, 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 M. So 4 elements it is there. So it is quite clear the given P cross Q and our calculated P cross Q are not same. So hence P cross Q is not equal to set of M, N, N, M. That is what our given set, which is not equal to our P cross Q, actual P cross Q. So the given statement is false. If the statement is false, we have to rewrite the given statement correctly. Quite clear, we have calculated here clearly, so let's write it. The correct statement is, if P is equal to M, N and Q is equal to N, N, then P cross Q will be set of these numbers, means M, N, M, N, and N, M. Then the second part, if A and B are non-empty sets. Non-empty set means you know that there will be number of elements. Some particular number of elements will be there in set A and set B. Then A cross B is a non-empty set of ordered pairs X, Y, such that X element of A and Y element of B, means A cross B. When we are crossing these two sets, in which these two sets are having elements, they are not empty sets. So A is having particular number of elements, B is also having particular number of elements. Then A cross B is a non-empty set, means A cross B also surely will be having a particular number of elements. Means if you write it as ordered pairs X, Y, the first element belongs to A and the second element belongs to B. This is what the given statement. Once again, two sets are there, they are non-empty sets, means elements are there. Then A cross B is also a non-empty set which will be having some elements, and that elements is in the form X, Y ordered pair, and first element belongs to the first set and the second element belongs to the second set. We have to verify that whether this statement is true or false. So while explaining them itself, some of you might have come to the conclusion that this is right or this is wrong. That means according to your conclusion. So this question you will try it as homework. Next we shall discuss the third question. If A is equal to set of 1, 2, B is equal to set of 3, 4, then A cross B intersection null set is a null set. A cross B intersection 5 is equal to 5. That is what the given statement. Here we have to check whether these statements are true or false. Here, first of all, we will go with finding out this B intersection 5. That means, first of all, B will write B is equal to set of 3, 4. Then we are asked to find out B intersection null set. Means B which is common with a null set. The elements which are common in B and a null set. As we know that null set is having no elements. Means here there is no element, here there are elements 3 and 4. B is having elements 3 and 4 and this null set is having no element. So how can we find the common terms? It's not possible. Means here there are no elements. Means there will be no common elements in these two sets. So it is a null set. B intersection null set is a null set. Next, A cross B intersection 5. A cross B intersection 5 means A is we have given 1, 2. Cross B intersection null set is a null set. So set of 1, 2 cross a null set. So here we are finding out a cross product with a null set where there is no element. As we know that in P cross Q, if one of set is a null set, then P cross Q is a null set. As we know that cross product means pairing one element with the first element of this set, and the second element also we are making pair with the elements of the second set. But this second set is having no elements. That means there is no way to make pair with the second set. That means we will be getting a null set. So the given statement is true here. Next we shall discuss question number 5. If A is equal to set of -1, 1, find A cross A cross A. Here A cross A cross A means 3 times you have to cross it. Very simple question, but little bit of confusion will be there if you are not concentrating it properly. So you have to take utmost care. Means careless mistakes, there are chances. So A cross A means A is -1, 1 is a set. So -1, 1 cross -1, 1 cross -1, 1. Let's write the first set. That means I am taking the first elements -1, -1, -1. So that I have written -1, -1, -1. Next again -1, -1. Here the second element I am taking. So -1, -1, 1. That is the first pair I have written. Ordered triplets. Here first triplet, here second triplet. Next -1. Next is here 1. Again -1. Means once again -1. Then from here 1. From here -1. Again next what you have to do is -1. The second element here 1. And here the second element 1. So -1, 1, 1 it's written. Now there are 4 elements. Then total you can see there 2 into 2 into 2, 8 elements should be there. We have only completed 4. Next 2 we can make. That is from here the second element we have to take 1, -1, -1 it's written. Next is 1, -1. Here the second element it is written. So now there are 6 elements. Now 2 more left. That is from here we can start 1, 1, -1. Again 1, 1, 1. So we have taken. Once again if you want I will explain. So just to check. First of all you have to take first elements -1, -1, -1. It's written. Next is -1, -1 and the second element here 1. It's written. Next is -1, 1, -1. Next is -1, 1. The last element here 1. Next is with this one 1, -1, -1. It's written. Next is 1. Here first element -1. Then here 1. It's written. Next is 1, 1, -1. It's written. Next is 1, 1, 1. That's all. So these are the 8 elements. 1, 2, 3, 4, 5, 6, 7, 8 triplets are there. That is what A cross A cross A. First of all you check how many elements will be there in the cross product. Then accordingly you adjust it. Then question number 6. If A cross B is equal to set of A, X, A, Y, B, X, B, Y, find A and B. The sets A and B we have to check. So it is quite clear. A means from here the first element if you collect A will get. And B, A cross B, B is the second set. Means here in the ordered pair second elements if you collect you will get the second set. So here given A cross B is equal to set of A, X, A, Y, B, X, B, Y. A is the set of all first elements. Here A is our first set. How do we get first set? When we collect first elements from these ordered pairs we will get the first set. Then B is the set of all second elements. Means B is our second set. How do we get the second set? From the ordered pair, we have to collect the second elements. So A is equal to, here first element, if you check, A is there, here A one more time is there, but we will take only one time. Then here it is B, B here repeating. So A and B only. So A comma B. Then B, when we check, here X is there, here Y is there, again X is repeating here, Y is also repeating. Means B is equal to X comma Y. Only one time we can write one element. So A is set of AB and B is equal to set of. Next we shall discuss question number 7. Question is, let A is equal to set of 1, 2, B is equal to set of 1, 2, 3, 4, C is equal to set of 5, 6 and D is equal to set of 5, 6, 7, 8. Verify that the first part, A cross B intersection C is equal to A cross B intersection A cross C. This is what we have to verify. A cross B intersection C is equal to A cross B intersection A cross C. So here, first of all, LHS part we can take. LHS is equal to the B intersection C part we need to calculate first. Then only we can take cross product with A. So B intersection C means B set, that is set of 1, 2, 3, 4, intersection set of 5, 6. Intersection means it is common for both the sets. Here 1 is not there, 2 is not there, 3 is not there, 4 also not there. Means there is no element which is common in both the sets, means it is a null set. Then next is A cross B intersection C, that is what the left hand side. A cross B intersection means A is set to 1, 2, set to 1, 2 cross 5. Means you have to find out a cross product with a set which is having no elements. We have discussed before, we cannot cross it because one element you have to take from here and we have to make pair with an element from this set. So here this set is having no element, it is a null set. Means it is not possible to make pair. Means it is a null set. So left hand side we have got as null set. Then right hand side we can take RHS. That is first part A cross B. A cross B means let's take A and B, set of 1, 2 cross set of 1, 2, 3, 4. Then we know that how to write the cross product. First element with all the elements here. That is 1, 1, 1, 2, 1, 3 and 1, 4. It's written. Next is second element with all the elements. That is 2, 1, 2, 2. 2, 3 and 2, 4. It's written. That is our A cross B. Next is A cross C we have to check. A cross C is equal to A and C we have to write and then cross it. First element with here with the 5, first element with the 6. That is 1, 5, 1, 6. Next is 2, 5, 2, 6. That's written. Then we have to go for A cross B intersection A cross C. A cross B intersection A cross C means we have to check the intersection. Intersection means common. A cross B is having these elements and A cross C is also having these are the elements. So it is quite clear there is no common elements. 1, 1 is not there, 1, 2 not there, 1, 3 not there, 1, 4 not there, 2, 1 not there, 2, 2 not there, 2, 3 and 2, 4 also not there. Means there is no common element. Directly we can write as 5. So LHS and RHS we have got 5 means it is verified. So A cross B intersection C is equal to A cross B intersection A cross C. Next is second part, A cross C is a subset of B cross D. Here A cross C we have to calculate first. Now we are quite familiar with the cross products. We know how to find out the cross products of two sets. A cross C we have to find out. Then B cross D also we have to find out. Then we have to verify A cross C is a subset of B cross D. Means subset definition we know that all the elements of A cross C must be there in B cross D. All the elements of A cross C must be there in B cross D. Then we can say that A cross C is a subset of B cross D. So this question you will try it as homework. Move on to the 8th question. Let A is equal to set of 1, 2, B is equal to set of 3, 4. Write A cross B. How many subsets will A cross B have? List them. There are two sets are given, A and B, and we have to write first A cross B. And how many subsets will A cross B have? A cross B is a set and we have to find out how many subsets will be there. So the number of subsets we know the formula 2 power n. Then not only writing the number of subsets, we have to list them also. So all the subsets we have to write. That is what the question. Simple question. So let's do it step by step. So here there are two sets, A and B is given. A is set of 1, 2 and B is equal to set of 3, 4. First of all, we will go for A cross B. That is what the first question, write A cross B. So we know how to write the cross products. 1 we have to make pair with 3. Again 1 pairing with 4. Then 2 pairing with 3, 2 pairing with 4. It's written A cross B. Then how many subsets will A cross B have? So A cross B means this is a set. So here 1, 2, 3, 4 elements are there. So number of elements of A cross B is 4. So number of subsets, we know the formula 2 power n. So 2 power n means 2 power 4. Means 2 multiplying 4 times 2 into 2 into 2 into 2, that is equal to 16. 2 into 2 4, 4 into 2 8, 8 into 2 16. So there are 16 subsets we can make from this set. So we are going to list them. Listing, we have to be very careful. So subset of A cross B, our A cross B is this one, set of 1 3, 1 4, 2 3, 2 4. So subsets writing, first of all we have to form a particular pattern. Then when we follow a pattern, then it will be easy for us to make the subset. First of all, let's go with the single elements. So one element means this set of 1 comma 3, that is one subset. Next is another element we can take, that is set of 1 comma 4. Next third element, that is set of 2 comma 3. Next is set of 2 comma 4. So all the single elements separated and we have formed a subset. Next with the two elements we can take 2 elements, that means 1 3 1 4, first 2 we have taken. Next is 1 3 2 3, first and third we have taken. Next is 1 3 2 4, first and fourth we have taken. Then next is 1 4 2 3, second and third we have taken. Then next is second and fourth, that is 1 4 2 4 we have taken. Next is 2 3 2 4, means third and fourth we have taken. Then with the 3 elements, 3 element means first 3 together we can take, that is 1 3 1 4 2 3 we have taken. Then next is 1 3 1 4 2 4, first second and fourth we have taken. First we have taken first, second, third, it is written here. Then first, second, fourth, it is here. Next is 1 3 2 3 2 4, second we have removed, first, third, fourth we have taken. Next is 1 4 2 3 2 4, first we have removed, 1 4 2 3 2 4, it's written. Then next is with 4 elements. 4 elements means 1 2 3 4, the entire set A cross B will be coming, that is 1 3 1 4 2 3 2 4. Next there is one more balance is there, that everybody knows, that is a null set. So these are the subsets. Next we shall discuss question number 9. Let A and B be two sets such that n of A is equal to 3, n of B is equal to 2. If x comma 1, y comma 2, z comma 1 are in A cross B, find A and B where x, y and z are distinct elements. So here there are two sets it is mentioned, A and B. Number of elements of A set is 3, number of elements of B set is 2, and there are 3 ordered pairs are given, x comma 1, y comma 2, z comma 1. These 3 ordered pairs belongs to A cross B. So we are asked to find out A and B. Quite simple question. So A cross B elements are x1, y comma 2, z comma 1, that is we have mentioned. And as we know that A cross B means our first set is A, second set is B. And when we write the ordered pair, first element belongs to first set and the second element belongs to second set. By using these conditions we can write A and B. Means A set is having x, y and z, all the first elements. So A is equal to set of x comma y comma z. Then B means we will be using B, as B is in second position, means A cross B, B is in second position, means here the second elements belongs to B set. 1 2 1 means 1 is repeating 2 times, 1 comma 2, that is enough. So B is equal to set of 1 2. These are set A and set B. Next is question number 10. The Cartesian product A cross A has 9 elements, among which are found minus 1 comma 0 and 0 comma 1. Find the set A and the remaining elements of A cross A. Here the Cartesian product A cross A has 9 elements. There are 9 elements in A cross A. Then 9 elements means A will be having 3 elements. 3 into 3, 9. So A cross A has 9 elements means surely A will be having 3 elements. And among these 9 elements in A cross A, minus 1 0 and 0 1, two elements are given. Find the set A and the remaining elements of A cross A. So here minus 1 0 is in set A cross A. It is given to us. Again 0 comma 1 is in set A cross A. So here first element belongs to first set, and here first set and the second set is same set only, because we are crossing with the same set A cross A. Means minus 1 belongs to A, 0 also belongs to A, and here 0, of course we have already discussed, 0 belongs to A, 1 belongs to A. Means minus 1 0 1, these are the three elements of A set. So A is equal to set of minus 1 0 1. 3 elements only will be there, then only 3 into 3 will be having 9 elements when we are crossing A cross A. Then A cross A is equal to minus 1 0 1 cross set minus 1 0 1. Let's find out the cross product. First element with each individual elements of the second set, that is minus 1 minus 1 minus 1, then 1, then next is minus 1 0, it's mentioned. Then next is 0 minus 1, next is 0 0, then next is 0 1, it's mentioned. Next is with the third element, that is 1 minus 1 1 0 1 1, these three elements. So total 9 elements we have. Now we can check here, the highlighted ones are our required elements. Means you can see here not highlighted one, minus 1 0, minus 1 0, it is given to us. And again here you can see 0 1 is not highlighted, that 0 1 also given to us. Means other than these two, the remaining all are our required elements. That means the remaining elements of set A cross A are minus 1 comma minus 1, minus 1 comma 1, the next is 0 comma minus 1, 0 comma 0, 1 comma minus 1, 1 comma 0 and 1 comma 1. So these are the remaining elements. Dear students, today we have discussed a new concept, that is the Cartesian products of sets, and we have solved first exercise questions. I request all the students to go through these definitions and exercise problems. While practicing, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.